Hello learners, I welcome you all to this session on data mining. What is data mining? Data mining is the analysis step of knowledge discovery in databases process or KDD. Data mining is the extraction of hidden predictive information from large databases. It is a new technology with great potential to help companies focus on the most important information in their data warehouses. Let us see the definition of data mining. It is non-trivial extraction of implicit, previously unknown and potentially useful information from data. It is the exploration and analysis by automatic or semi-automatic means of large quantities of data in order to discover meaningful patterns. Let us see the purpose of data extraction. Data mining is defined as the procedure to extract information from huge sets of data. We can say that data mining is mining knowledge from data. There are a huge amount of data available in the information industry. In extraction, the information is not the only process we need to perform. It also involves other processes such as data cleaning, data integration, data transformation, data mining, pattern evaluation and data presentation. When all these processes are over, we would be able to use this information in many applications such as fraud detection, market analysis, production control and science exploration. What is data mining process? Data mining is the process of discovering patterns from large data sets involving methods at the intersection of machine learning, statistics and database systems. Data mining is an interdisciplinary subfield of computer science and statistics with an overall goal to extract information from a data set and transform the information into a comprehensible structure for further use. Aside from the raw analysis step, it also involves database and data management aspects, data pre-processing, model and inference considerations, interestingness metrics, complexity considerations, post-processing of discovered structures, visualization and online updation. The term data mining is in fact a misnomer because the goal is the extraction of patterns and knowledge from large amounts of data. It is not the extraction of data itself. We have to remember that it is also a buzzword and is frequently applied to any form of large scale data or information processing as well as any application of computer decision support system, including artificial intelligence and business intelligence. Practical machine learning tools and techniques with Java was original to be named just practical machine learning, and the term data mining was only added for marketing reasons. Often the more general terms data analysis and analytics, or when referring to actual methods, artificial intelligence and machine learning are more appropriate. The actual data mining task is the semi-automatic or automatic analysis of large quantities of data to extract previously unknown, interesting patterns such as groups of data records, unusual records and dependencies. This usually involves using database techniques such as spatial indices. These patterns can be seen as a kind of summary of the input data and may be used in the further analysis, for example, in machine learning and predictive analytics. The data mining step might identify multiple groups in the data, which can be used to obtain more accurate prediction results by a decision support system. The data collection, data preparation, nor result interpretation and reporting is part of the data mining step. The related terms data dredging, data fishing and data snooping refer to the use of data mining methods to sample parts of a larger data set that are too small for reliable statistical inferences to be made about the validity of any patterns discovered. These methods can be used in creating new hypotheses to test against the larger data populations. Now, let us see the history of data mining. In the 1960s, analysts and economists use terms like data fishing or data dredging to refer to what they considered the bad practice of analyzing data without an a priori hypothesis. The term data mining was used in a similar critical way by economist Michael Lowell in an article published in the Review of Economic Studies in 1983. In this study, Lowell indicates that the practice masquerades under a variety of aliases ranging from experimentation to fishing or snooping. Next, the term data mining appeared around 1990 in the database community, generally with positive connotations. For a short time in the 1980s, a phrase database mining, trademarked, was used, but since it was trademarked, researchers consequently turned to data mining. Other terms used include data geographer, information harvesting, information discovery, knowledge extraction, etc. Gregory Piatsky-Shapiro coined the term knowledge discovery in databases for the first workshop on the same topic, KDD 1989. And this term became more popular in AI, that is artificial intelligence, and machine learning community. The term data mining became more popular in the business and press communities, and the terms data mining and knowledge discovery are used interchangeably. This is a brief history on the term on data mining. In the academic community, the major forums for research started in 1995. When the first international conference on data mining and knowledge discovery, that is KDD 95, was started in Montreal under AAAI sponsorship. It was co-chaired by Usama Fayyad and Ramasamy Uthurasamy. Later in 1996, Usama Fayyad launched the journal by Clover called Data Mining and Knowledge Discovery as its founding editor-in-chief. Later, he started the SIG KDD newsletter, the SIG KDD Explorations. The KDD International Conference became the main highest quality conference in data mining with an acceptance rate of research paper submissions below 18%. The journal Data Mining and Knowledge Discovery is the primary research journal of the field. The manual extraction in the patterns for data has occurred for centuries. Early methods of identifying patterns in data include Bayes' theorem in the 1700s and regression analysis at 1800s. The boost, ubiquity and increasing power of computer technology have dramatically increased data collection, storage and manipulation ability. The data sets have grown in size and complexity. Direct hands-on data analysis has increasingly been augmented with indirect automated data processing, aided by other discoveries in computer science such as neural networks, cluster analysis, genetic algorithms in the 1950s, decision trees and decision rules in the 1960s, and support vector machines in the 1990s. Data mining is the process of applying all these methods with the intention of uncovering hidden patterns in large data sets. It bridges the gap from applied statistics and artificial intelligence, which usually provides the mathematical background to database management, by exploiting the way data is stored and indexed in databases to execute the actual learning and discovery algorithms more efficiently, thereby allowing such methods to be applied to ever larger data sets. Types of processes in data mining. Now, let us see the main steps which are involved in the process of data mining. KDD process is commonly defined with these stages. First one is selection, the second one is pre-processing of the data, third one is transformation of data, fourth one is data mining, and the fifth one is interpretation or evaluation of the results acquired. Let us see the first step, data selection. Data mining process requires a large volume of historical data for analysis, so that the data repository with integrated data contains much more data than actually required. From the available data, the data needs to be selected and stored. From the data, a selection is a process where the data relevant to the analysis is retrieved from the database. That is, if we have a large amount of data, the entire data cannot be used as it is. From the given data, we have to select the most important data that has to be used for the next step. Let us see what is data pre-processing. Data pre-processing is data mining techniques that involve transforming the raw data into an understandable format. In the real world, data is often incomplete, inconsistent and or lacking in certain behaviors or trends and is likely to contain many errors. You would have seen many such data sets in your real-time analysis. Data pre-processing is therefore a proven method for resolving such issues, to remove the unwanted data and to clear the data. Data pre-processing prepares raw data for further processing. Data pre-processing is used in the database as driven applications such as customer relationship management and rule-based applications. The next step following data pre-processing is data transformation. Data transformation is the process of transforming and consolidating the data into different forms that are suitable for data mining. Data transformation normally involves normalization, aggregation, generalization, etc. For example, a data set available as -5, 37, 100, 89 and 78, where we find 5 values. It can be transformed as -0.05, 0.37, 1.00, 0.89 and 0.78 so that all the 5 values lies below 1. Here data becomes more suitable for data mining. After data integration, the available data is ready for data mining. Followed by data pre-processing and data transformation, we have the data mining step. Data mining is a core process where a number of complex and intelligent methods are applied to extract patterns from the data set. In the data mining process, it includes a number of tasks such as association, classification, prediction, clustering, time series analysis and many. Followed by this, we have the evaluation. The pattern evaluation will identify the truly interesting patterns representing knowledge based on different types of interestingness measures. A pattern is considered to be interesting if it is potentially useful and it can be easily understandable by humans and it validates some hypothesis that someone wants to confirm or valid on new data with some degree of certainty. The process will exist in the cross-industry standard process for data mining, that is CRISP-DM, which defines 6 phases. The first phase is business understanding, the second one is data understanding, the third one is data preparation, fourth one is modeling, followed by evaluation and deployment. Polls conducted in 2002, 2004, 2007 and 2014 show that the CRISP-DM methodology is the leading methodology used by data miners. The only other data mining standard named on these polls was SEMMA. However, 3 to 4 times as many people reported using CRISP-DM. Several teams of researchers have published reviews of data mining process models. Pre-processing. Before the data mining algorithms were used, a target dataset must be assembled. The data mining can only uncover patterns actually present in the data and the target dataset must be large enough to contain these patterns while remaining concise enough to be mined within an acceptable time limit. A common source for data is a data mart or data warehouse. Pre-processing is essential to analyze the multivariate datasets before data mining were used. The target is set and then cleaned. Data cleaning will remove the observations containing noise and those with missing data. Let us see the data mining task. The data mining involves 6 common classes of tasks. The first one, anomaly detection, that is outlier or change or deviation detection. Here we do the identification of unusual data records that might be interesting or data errors that require further investigation. Next one is association rule learning or dependency modeling. This searches for relationship between variables. For example, A supermarket might gather the data from their customers' purchasing habits. Using association rule learning, the supermarket can determine which products are frequently bought together and use this information for marketing purposes. This is sometimes referred as market basket analysis. The other step is clustering, that is the task of discovering groups and structures in the data that are in some way or another similar without using known structures in the data. Next one is classification. Here the task of generalizing known structure to apply to new data. It is the task of generalizing known structure to apply to new data. For example, an email program might attempt to classify an email as legitimate or as spam. This is a simple example of classification. Regression. Regression attempts to find a function which models the data with the least error, that is for estimating the relationships among data or data sets. The another step is summarization. It provides a more compact representation of the data set, including visualization and report generation. Next we come to an example of results validation. Here you can see a graph plotted, you can see the x and y axis. In the above example, the data produced by data dredging through a bot operated by statistician Tyler Wiegand, apparently showing a close link between the best world winning spelling bee competitions and the number of people in the United States killed by venomous spiders. The similarity in trends is obviously a collaboration. We should not interpret this as a relationship is existing between them. We need to be very careful in this. Data mining can accidentally be misused and can then produce results which appear to be significant, but which do not actually predict future behavior and cannot be reproduced on a new sample of data and move little use. Often this results from exploring too many hypotheses and not performing proper statistical hypothesis testing. A simple version of this kind of problem in machine learning is known as overfitting. But the same problem can arise at different phases of the process, and thus a train or test split, when applicable at all, may not be sufficient to prevent this from happening. The final step of knowledge discovery from data is to verify that the patterns produced by the data mining algorithms which occur in the wider data set. Not all patterns found by the data mining algorithms are necessarily a valid one. It is common for the data mining algorithms to find patterns from the training set which are not present in the general data set. This is called as overfitting. Hence, to overcome the overfitting, the evaluation uses a test set of data on which the data mining algorithm was not trained. The learned patterns are applied from the test set and the resulting output is compared to the desired output. For instance, a data mining algorithm trying to distinguish spam mail from legitimate emails would be trained on a training set of sample emails. Once trained, the learned patterns would be applied to the test set of emails on which it had not been trained. The accuracy of the patterns can then be measured from how many emails they correctly classify. A number of statistical methods may be used to evaluate the algorithm, such as ROC curves. If the learned patterns do not meet the desired standards, subsequently it is necessary to re-evaluate and change the pre-processing and the data mining steps. If the learned patterns meet the desired standards, then the final step is to interpret the learned patterns and turn them into knowledge. What are the applications of data mining? There are a wide range of data mining techniques, algorithms, which can be applied in all kinds of domains where data has to be analyzed. Let us see some examples of the data mining applications. Fraud detection, stock market price prediction, analyzing the behavior of customers in terms of what they buy. These are just a few, but there are many more applications. In general, data mining techniques are chosen based on the type of data to be analyzed, the type of knowledge or patterns to be extracted from the data, and how the knowledge will be used. These are the criteria by which we have to select the data mining technique which has to be applied for our customized data set. What are the main data mining software? To perform data mining, there are many software programs available in this world. Some of them are general purpose tools offering many algorithms of different kinds, while others are more specialized. Also, some software programs are commercial while others are open source. Hence, it is up to the learner or the researcher to find out which algorithm suits their area the best. The SPMF open source data mining library, which is free and open source and specialized in discovering patterns from data. Now, we have seen an overall idea of what is data mining, the definitions for data mining, the various steps in data mining, its applications and the algorithms which are most commonly used in data mining. Apart from this, you have got some idea on what are all the software which are used in data mining. Hope you can use this knowledge and effectively mine your data for your analysis and research. Thank you.